All right, students, you should have just finished your quiz over verifying and proving trig identities, and we're now moving into the next section, which is solving trig equations. I want you to start off working on these three warm-up problems. On this whole video, I'll ask you to work on problems while the video is paused and then come back and check your answers. So right now, go ahead and pause this and answer these three questions and then come back. All right, so you should have just solved these. And for the first one, you should have gotten that sine of x equals square root of 2 over 2, and you're just using your unit circle, and you know sine's positive in the first and fourth quadrant, so you should have just gotten that sign that the x value is pi over 4 and 3 pi over 4. Over here on the right, to solve this, you should have just recognized you had to take the square root of both sides. I do have a feeling most students forgot the plus and negative 1 is the square root of 1. And then by solving this, you're then getting three answers, which is 0, pi, and 2 pi. The next one just brings us back to algebra 2, and all it is it's using the zero product property. If you have two factors that multiply to be equal to 0, you can set each of those factors equal to 0, and when you solve it, you just get x equals -4 and x equals 3. All three of these ideas are going to come up at different times while you're solving some of these trig equations. So here's two problems. What you should be able to see is on the left side, it looks like a trig, like half of a trig identity. So you're just going to simplify that whole left side and see what you can come up with to then solve for x. So go ahead and pause the video and then turn it back on for the solution. All right, so on here, what you should have seen on the left side is you could have factored out a cosine of x and then been left with sine x plus 1. You're then using the zero product property to set each of these factors equal to 0. And then on the right side, you can subtract 1 from each side, and you're just solving these basic trig identities. So cosine of x equals 0 at pi over 2 and 3 pi over 2. And sine of x equals -1 at 3 pi over 2. And you do not need to write the answer twice over there. Number 2 is a little bit more difficult. Hopefully you saw that you can replace 2 sine x cosine x with sine of 2x. And then we're going to go back to last semester how we used inverses. The angle 2x is equal to the inverse sine of -1. And that means what angle sine is -1? And what angle sine is +1? And hopefully you realize that's at pi over 2. So at this point you just have 2x equals pi over 2. And in order to get x alone, you can multiply both sides by 1/2 or divide by 2, either way, and you get x equals pi over 4. All right, two more problems. Work on these two with the video paused, and then come back and check your answers. All right, so you should have just worked on these two problems, and here's what you should have come up with. On this left side, 1 over cosine squared x, you should get sine squared x. Then you should say, hey, these simplify. Sine squared x over sine x is sine x. And then you're just solving this basic trig equation to get pi over 4 and 3 pi over 4. On this right side, in order to subtract fractions, you need a common denominator. So I took tangent x and I multiplied by tangent x over tangent x. Then at that point, I get tangent squared x minus secant squared x, tangent squared x over tangent x minus secant squared x over tan x. And at this point, I'm able to subtract my fractions and use that common denominator. And when I see this all in the numerator, I recognize that it's one of the Pythagorean identities that's just a little bit transformed. So if I subtract secant squared x over to this side, I can subtract -1 over here. So this whole numerator equals -1. And there's different ways to solve it from here, and here's just the way that I went about it. I multiplied both sides by -1. I then get 1 over tangent x equals -square root of 3 over 2. 1 over tangent x is cotangent x. And cotangent x is cosine x over sine x. And I knew that -square root of 3 was -square root of 3 over 2 over 1/2. That got reduced. So I'm looking for where's my x coordinate, -square root of 3 over 2, and my y coordinate, the 1/2. And I knew that happens in quadrant 2 and 4 at 5 pi over 6 and 11 pi over 6. All right, two more problems. Work on these, pause the video, and then come back. All right, so you should have checked your answers or worked on the problems, and here's the answers. So over here, one way that I went about it, and just so you know, there are many ways to go about doing these problems. I split this up to be sine x over sine x plus tan x over sine x. I knew that sine x over sine x is 1, and I subtracted 1 over to the other side to get tangent x over sine x equals 2. I split tangent up to be sine x over cosine x, still over that sine x over 1. And then to simplify a fraction divided by a fraction, I kept the numerator the same and multiplied by the reciprocal of the denominator. The sine x's cancel out, and I'm left with 1 over cosine x equals 2, or you can even think of that as 2 over 1. I recognize that as a proportion, and I know that proportions, you can flip both sides of the fraction to get cosine x equals 1, equals 1/2. And you're solving that now. I know cosine's positive in quadrants 1 and 4, so the answer is pi over 3 and 5 pi over 3. And the last one, this was quite a bit of work on here. See two fractions that are being added. In order to do that, I needed to get a common denominator. 1 minus cosine x over 1 minus cosine x, and 1 plus cosine x over 1 plus cosine x. When I do that, my numerator is 1 minus cosine x over 1 minus cosine squared x, and 1 plus cosine x over 1 minus cosine squared x. When I combine my fractions, my numerator becomes this, and I can see I have a negative cosine x plus a cosine x, which just adds up to be 0. So I'm just left with 1 plus 1 in the top, which is 2, over 1 minus cosine squared x. At this point, I recognize a proportion again, so I flip both sides. I multiply both sides by 2, so I have 1 minus cosine squared x equals 1. And there's two ways to solve this problem. The first way that I went is I changed 1 minus cosine squared x to be sine squared x equals 1, square root both sides, and I'm getting that x is pi over 2 and 3 pi over 2. Other students might recognize this, that you can subtract 1 from both sides to get cosine squared x equals 0. And then when you square root both sides, you just get cosine x equals 0, and that happens at pi over 2 and 3 pi over 2. If you have any questions, please come in at North Time and ask. Right now you are working on your homework sheet, and there are an awful lot of problems on there, so get done as many as you can, and come in with questions on Friday, and this will be due on Monday. Have a good day.